Hello and welcome back. In about 1 month, it will be exams for most of you guys. And I remember when I was a high school student, the problem I used to have is that even though I studied throughout the year and I tried to revise all the concepts, but when it came to actually solving a problem or a past paper question, my mind somehow struggled to connect these different ideas together to solve a problem. It was very late when I figured it out that the main reason for this type of problem is that revising physics and solving exam questions and problems, these are very different techniques or skills that you need to develop. You need to understand physics separately, and then you need to learn how to solve puzzles and problems separately to develop this skill. So if you're having the same problem just 1 month before the exam, you cannot solve exam questions, then this video is for you. Make sure you watch the whole video and I'm sure you will find it very useful. In my last video, I showed how you can solve a problem, a past paper question. Even if you don't have a perfect understanding of physics or waves, you can still solve this problem. In this video, I want to focus specifically on multiple choice problems. The first thing that you should remember is that the approach that we use to solve an extensive response question and a multiple choice question, these are very different because in multiple choice questions, you have a limited time and each question has only 1 mark. So you have to be very careful of this thing that you should not be spending more than 1 minute on one multiple choice problem. And this is what I will try and teach you how you can use different techniques to solve a multiple choice question in under 1 minute. And to do that, the first thing would be to quickly read the question and try to connect this question to a bigger concept. Now, if you read this question and think of, let's say, free fall or gravity, these are somewhat related concepts. For example, projectile motion would be way too off if you try to connect it to projectile motion. But if after reading the question, some of you guys are thinking about net force, then congratulations, you have understood the point. So this is the main skill that you need to develop, reading the question and just thinking about net force. Maybe you can also think about, for example, third law, Newton's third law, action and reaction. This would also be the right way to think about this problem, but you should think about either this net force or third law. Both of these things will help you solve this question in under 1 minute. So let's try to solve this question using net force. At this instant, when the ball is in contact with the ground, this is just one instant in a full kind of motion. The ball is hitting the ground and then it bounces vertically upwards, right? So if I ask you what will be the net force at this instant, what will be the direction of the net force at this instant? The net force should be pointing upwards. As soon as you understand this thing, you can look at the options, and that's where you can apply the second technique for multiple choice questions. And the trick is to eliminate the wrong answers. Because if you're making, let's say, a wild guess between 4 options, you have a 25% chance of getting the right answer. But let's say if you just eliminate this option C, because you can see the net force is equal to weight acting on the ball. Both of these forces are acting on the ball. And if this option was correct, then the net force on the ball would be 0, which goes against our understanding, right? The ball has to bounce up. The net force should be pointing up, and that's why C cannot be the right answer. Now, immediately after eliminating this option, you have 33% chance of getting the right answer. If you can somehow eliminate 1 or 2 more options, then that's it. You have the right answer. Let's look at A and B. So let's look at option A, N equals P plus W. First thing, this is not an equation of the net force on the ball, first of all, because if you understand net force, for net force, you have to add all the forces that are acting on an object, on one object. This P is not acting on the ball. P is acting on the ground by the ball, right? So in the net force equation, which you write for the ball, P will not be a part of that equation. But even if, let's say, P was a force acting on this ball, or let's say you forgot that P is not acting on the ball, it is acting on the ground, you don't understand this thing. Even if you included this P as a force acting on the ball, even then this equation would be wrong, because even then you would get net force of 0, because W is acting down, P is acting down, and N is acting upwards. And if they are all balancing each other, the ball would not move up, right? So A cannot also be true. First of all, because this is not the equation of net force for the ball, P should not be here. And even if it was a force on the ball, even then option A cannot be correct. Now at this point, it is kind of difficult to choose between option D and option B. But what you should understand is that you have a 50-50 chance of getting the right answer. Before that, you had 25% chance. So you're still, I would say, in a much better situation to solve this question in under 1 minute. You have a 50-50 chance. But if you combine this third law with net force, you can further eliminate the wrong answer. Because you see, this normal force and this contact force P, these forces are Newton's third law pairs. So what it means is that if the ball was not in contact with the ground, both of these forces would not exist. Most of the students think that normal force is the reaction force because of weight of the object. For example, if I draw a box sitting on some surface, most of students, if I ask them to draw all the forces acting on the box, they will draw weight and the normal force acting upwards. And if I ask them, are these two Newton's third law pairs, action and reaction, they say yes, they are. But you can see they are not action and reaction pairs. This normal force upwards and the contact force P acting on the ground because of the ball, these are third law pairs, which means that normal force should be equal, exactly equal and opposite to this contact force P, because in third law, action and reaction are always equal and opposite. And if you understand this, then what we can do is we can replace P with N in this equation. And then this equation would be N is greater than N plus W. Again, which doesn't make sense, because if you just subtract N from both sides, you see that, and if you solve this equation will give you that 0 is greater than weight, which doesn't make any sense. You could do the same thing here with A also. If you understand this third law, you can replace P with N in this equation, and this will give you N equals N plus W. And again, you can subtract N from both sides and you will get 0 equals to weight. Again, this is also not true. So you see, if you are just focused on the right answer, I don't think you will choose D as the right answer. But if you also look at the wrong answers and eliminate the wrong answers, then D is the only option that you have, which also is consistent with our understanding of the net force, that the upward force, which is the normal force, should be greater than the weight at this instant. Now, it took me about 3 minutes, maybe, or 4 even, to explain all of this, but it is because I was explaining the whole idea behind applying this technique. If you just practice these things and you keep practicing, solve 10, 20, 50 multiple choice questions like this, you will see that after 20, 30 problems, you will be solving these type of questions in under 1 minute. Let's look at another question. Again, stop the video, read the question, try to think of the main topic, and just look at the options. So the main topic would be, for example, waves. Waves, still, it is a very broad topic, but you will see how we can narrow this down to exact one specific topic within waves by reading the question. So the question asks, which row of the table describes the movement of F and G as one complete wave passes? So the first thing you should understand is that on a wave, each particle just moves up and down, right? Each particle keeps moving up and down at its fixed position. It doesn't move along the wave. So G and F will not move left and right. They'll just move up and down. Another thing is that one complete cycle of a wave. So one complete cycle would be like one oscillation. So what you have to understand is just this one concept, one oscillation. So how will this point F move in one complete oscillation? At this point, again, you can just look at the options, and again, you can try to eliminate the wrong answers. Another tip that I can give you is that whenever you are given 2 columns, you just focus on one of the columns first, okay? Try to get the right answer for the first column, and then automatically it will be easier to get the right for the second column. So we know that this end of the wave is moving down, right? If it is a normal wave, You cannot imagine that this point will move upwards, because then it will just change this shape of the wave. So this end is moving down. That tells you that this point F will also be moving down in initially. So for example, any option that says up for point F, you can just eliminate this option D because it says up. And now you have to think about how will one complete cycle of this point F look like. So you have to ask, is F is at its extreme position in its motion? So we know that point F just keeps moving up and down. The highest point on the wave is this point. So it means all the points will oscillate between this extreme, and this is the lowest point on the wave. And it means all the points will oscillate between these extremes. As you can see, F is not at one of these extremes. F is below the highest point and it is moving downwards. So what will happen in one complete cycle? So point F will move to this extreme down, and then it will start moving upwards, because one complete oscillation means that a point must return to its original position where we started observing this point F. So it will reach this extreme, then it will move up to this positive extreme, and then it will move again down and reach the original starting position. This will be one complete oscillation. You have to be careful that when it is moving back up, and let's say it reaches the same height, this position of F will not be considered one complete oscillation, because this is not the same as the starting point. The starting point is this height, and at this instant F is moving downwards. Now here F is again at the same height, but it is in the process of moving upwards. So these are not the same instance, or these are not the same points. The same point will be when F reaches the maximum extreme upwards and then starts moving down and reaches the same height. This will be the same instant that we started with. So we can also eliminate, for example, down then up, because we can see these are three steps: down, up, and then again down. So any option that says two of these things we can eliminate, and C is the right option. So in this case, you don't even have to look at the second column, G, because all these other options we have eliminated, and C is the right option.